This will be lesson 13, and I've imported the site terrain locating it in SketchUp. You'll remember from the sun video that the angle, the total rotation from true north was 24 degrees. It was, School Street was as 4 degrees short of the horizontal perpendicular to true north, and then true north itself was 20 degrees from straight up and down vertical. So if we go to a top view, and let's turn this mode so we can sort of see through the site. We expect that if I take all of this stuff that is currently locked, we'll have to unlock it. And let's make sure that we can't move it independently. I don't remember if, yeah. So we'll have to group the terrain. Let's group the terrain and the location snapshot together. We should be able to fence select it. Okay, so part of that is locked. That's locked. Let's unlock that. Let's fence select all of this and make it a group. Okay, let's go back. Plan view. And if I've done this right, we should be able to take this group and rotate it (24 degrees) that way. And that should give us, that should align us perfectly with the building. And it looks pretty close. I'm going to take and move from this corner, if I can, to, here's the problem. SketchUp is going to want to snap to geometry, so I need to basically move this orthographically. I'm first going to move along the green axis. So I want to lock this in place. Let's zoom out. Until that alignment appears to be correct. And then I want to move it along the red axis. And I'm locking that axis in place. Because if I snap to the model, it'll jump up to whatever vertical elevation of the geometry. So that looks about right. Let's go to a front view and make certain that we haven't. Good. And you can see even at this point the slope of School Street downwards. So if I go to a back view, we're actually looking at the model with respect to School Street. That looks fairly good. So if I change, turn off transparent faces X-ray, it might need to come up a little bit, and we'll look at that more closely in a minute. Let's talk about solar north now. We know if we're looking at a top view of the site, right? So now the site has been rotated, the terrain, topography, whatever associated with the site has been rotated to our model. Now we need to place solar north to its correct location. Solar north is going to be 24 degrees that way. Okay, we'll have to figure out what that angle is. You can see, though, even from this view, that it needs to be parallel to the drawing that represents the surface topography there. So if I subtract from 360 24 degrees, I get 336 degrees. So let's see if I can type that in explicitly. I can't. Let's see if I can somehow snap to it. 337, 336.6. I know there's a way to do this exactly. It's escaping me right now. Let's settle for 336.6. So there's north. So now when I turn on shadows, and if I set I think it's UTC -7, and set July around approximately 12 p.m. Let me pause this a second. So I'm looking down School Street from the point of view. I'm trying to approximate this point of view. So let's see how I can do that. Let me switch my camera back to parallel. So how can I do that? Basically, I'm going to set up what is effectively the equivalent of like a tripod. I'm drawing a line in the vertical direction on the blue axis about the height of that, say, that Google car camera might be. And let's say 10 feet. And I'm going to use the top of that to position my camera. So position camera at that endpoint, and I'm going to look toward these people. And then I'm going to switch my camera back to perspective. So let's zoom out a little bit. That's roughly, very approximately what I'm looking at. High sun angle, 8:30 a.m. So I can live with it, and let's save this scene. Let's rename it Google Camera Down School Street. When you save the scene, it saves the sun settings and all that other, along with the visibility settings for the and styles for the view. If I were to position the camera at one of these people looking back toward this way, I could do that as well. Let's go to an isometric view. Change camera back to parallel. So let's say I wanted to position camera at the eye level of one of these people and then drag toward my tripod. Right, so now I'm looking the other way. Change camera back to perspective. Zoom out a little bit. And now I'm getting a point of view as if I'm looking back at that Google car that was taking a picture from here. Let's see if we can do that at School Street. Or if I wanted to approximate this view, let's say I wanted to do this, I could go back here go back to an isometric view, change the camera back to parallel. I'm underneath the site right now. Whenever this happens, you can recenter by zooming extent. So I want my tripod, if you will, to be somewhere over here, looking back that way. Let's see. I am in the street, halfway down. Let's see if we can guess. I'm guessing I'm about here, looking toward the new building. So I'm On the blue axis, 6 feet. And let's camera, position camera, at the top of this, and then aim at the building, some intersection of the building. Let go of it and change your camera back to perspective. Note there's some geometry adjustments that we'll have to make. Does that look about right? No, I'm further back than that, so I'll have to zoom out a bit. Right? And you can make a little bit of an adjustment. A little more obliquely with respect to School Street, a little further out. And the sun may, well, let's go into shadows and see that maybe that UTC needs to be moved to 4 to 5. That's about the angle that we're looking at of the sun. So you can see it with respect to the patterns being cast, the shadow patterns being cast along this wall. Right? So that's pretty close. So we'll stop there. We will need to make adjustments to the geometry, and clearly we've made approximations for the columns, the exterior custom columns here, and the massive concrete beams that are holding this building up. So we've approximated them with very simple shapes, namely circular columns and rectangular concrete beams.